Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department. I welcome you all to this NPTEL course on traction engineering. This is lecture 20 where I will try to do some tutorials related to computation of tractive performance using Brixius model. So, what I will cover here is how to find out the dynamic weight on the front and the rear axle of a tractor. Then I will try to compute the tractive performance parameters of a tractor using prediction equations. The first problem is a 50 HP two-wheel drive tractor with a total weight of 2400 kg has the option of fitting either 13.628 or 16.928 tire on the rear axle. So, you have to select a suitable tire size if the tractor is to be operated most of the time in horizontal surface areas with an average cone index of 1200 kilopascal and with a static weight distribution of 35 and 65% at the front and the rear axles respectively. And the del by H ratio is to be taken as 0.2 and the aspect ratio is to be taken as 0.75, and there is no weight transfer during its operation in the field. That means here the basic aim is to find out what is the equation which you are going to utilize for computing this or for selecting a suitable tire. So, it is again the coefficient of rolling resistance, that is the main parameter, and coefficient of gross traction. These are the two parameters which can be utilized to select a suitable tire. So, as you know, Brixius equations, first thing is we have to calculate the mobility number. So, mobility number, for calculating mobility number, we have to find out what is the tire diameter. So, tire diameter, there are two tire specifications are given. One is 13.628 tire, the other one is 16.928 tire. So, if del by H ratio is 0.2 and aspect ratio is 0.75, so diameter I can easily calculate 1.06 into 28 plus twice into 0.75 into 13.6. So, again I multiply with 0.254, so that will give you 1.27 meter. The same procedure I follow to find out for 16.928 tire, 1.06 into 28 plus 2 into 0.75 into 16.9 into 0.254, that will give us 1.397 meter. So, this is the diameter. Now, section width you calculate, simply you multiply 13.6. So, here section width will be 13.6 into 0.254 and here it will be 16.9 into 0.254. So, first you calculate, suppose this tire is BN1 and this tire is BN2. So, mobility number for tire 1 is denoted as BN1, mobility number of tire 2 is denoted as BN2. So, we calculate CIBD upon W into 1 plus 5 del by H by 1 plus 3 B by D. So, W will be equal to your single wheel you have to calculate, since the tractor is operating on a horizontal surface. So, weight is given, weight distribution is given. So, 2400 into 0.65, so that will give you the weight coming on the rear axle, and 2400 into 0.35, that will give you the weight coming in the front axle. So, half of that will be your W. So, by this way we calculate mobility number, and then you can compare the mobility number itself. So, which one is higher or which one is lower. Then we calculate the rolling resistance or motion resistance ratio, rolling resistance ratio. So, that is nothing but 1 upon Bn plus 0.5 S by Bn plus 0.04, the square root of dn. Now, in this case, since slip is not given, so what you have to do is, you can assume a slip value of 10% and then compute rolling resistance for wheel 1, rolling resistance for wheel 2, and then compare which one will give you lesser wheel resistance. So, the wheel which is giving lesser resistance, that is better. To further what we can do is, we can compute the coefficient of gross traction to ensure that yes, we have more tractive effort. Okay. So, first thing is mobility number, second thing is rolling resistance, third is optional. From rolling resistance itself, we can conclude that this tire is better, which one is giving you lesser rolling resistance ratio. But you can always calculate the coefficient of gross traction. From there also you can conclude which tractor is giving you more coefficient gross traction, and the difference from there you can calculate to find out which one will give you more power or more pull. So, from there you can make a selection which tire is better. Next problem will be related to dynamic weight. A two-wheel drive tractor with a gross weight of 19 kilonewton has a wheelbase of 2.1 meter and is fitted with 616 tire at the front, 13.628 bias ply tire at the rear axle, and on a level ground, its center of gravity is located at a distance of 75 centimeter from the rear axle. The tractor will be used for plowing a farmland with an average cone index of 1000 kilopascal using a two-bottom moldboard plow. The total pull on the plow in the vertical plane is 250 kg, and it is an angle 15 degree with the horizontal when operated at a depth of 15 centimeter. Then the point of resistance, center of resistance is located at 125 centimeter behind the center line of the rear axle of the tractor and 15 centimeter below the wheel. So, what you have to compute is the coefficient of traction, tractive efficiency of the tractor when the slip is 20% and del by H ratio is 0.2. So, as usual, the first thing is you have to calculate the diameter, you have to calculate the section width, then comes your, there is some weight transfer. So, first you have to draw the tractor, this is the this is R2 and this is your CG. So, weight is acting 19 kilonewton and line of pull is say it is saying 15 degree to the horizontal. So, line of pull is somewhere here and it is 15 centimeter below the ground. If this is the ground surface, suppose this is the line of pull, and so line of pull I can resolve at this point into two components, vertical component and horizontal component. Then what is given is, this is making an angle 15 degree. So, that means this component will be P cos 15 degree and the vertical component is B sin 15 degree. Now, we have to find out what is the dynamic weight because of the pull. So, you have to take moments about R1 so that you can find out what is the dynamic weight in the rear wheel. Similarly, you have to take moment about R2 and then find out what is the dynamic weight on the front axle. So, now if you take suppose these are the points A and B, now taking moments about B. So, P cos alpha, P cos 15 into 0.15. This distance is from the ground is 15 centimeter. So, 0.15. Then this is positive and then P sin 15, this is also positive, sorry, this is acting downward, so this is negative, so minus P sin 15, and this is at a distance from the center is given as 125 centimeter from the rear of the center of the rear axle. So 1.25 centimeter. So into 1.25. Then W is again positive. So W is 19. W you can take as 19 kilonewton into this distance is at a 75 centimeter, that is 0.75. Then R1 is negative, minus R1 into 2.1. Wheelbase is given as 2.1 meter. So if you solve it, so you will find out expression. P is given as 250 kg. So you will find out R1 has some value. So similar exercise you have to carry out for by taking moment about B. This is taking moment about A. Similarly, by taking moment about A, so you'll get an equation. Equilibrium of moments will be if you are taking, this is again positive, P cos 15 degree into 0.15, then P sin, this is minus again, P sin 15 degree into 1.25. Now W will be, about B, not about B. So P cos 15 is okay, this is minus, okay. Now W will be minus. W, this is about B, okay. So W minus W into distance will be 2.1 minus 0.75, and then R2 plus R2 into 2.1. This is the equation. Now from here you can find, knowing P is given, so knowing W is given, so you can find out what is R2 value. So these are the dynamic weight, this R2 and R1, these are the dynamic weight, R1, these are the dynamic weight coming on the front and rear axles respectively. R1 in the front axle, R2 in the rear axle. So then half of that, if you say that it is on a horizontal surface, then half of that will act on each of the wheels. Now next thing is we have to calculate the coefficient of traction. Once you decided what is the dynamic weight, next thing is calculate the coefficient of traction. For calculating coefficient of traction, you have to take the torque ratio given by Brixius, then coefficient of rolling resistance given by Brixius, and again we have to calculate the mobility number. So there CI d by W, again CI is given, B is given, D is given, and W will be coming whatever R2 value you are getting here divided by 2, and for front wheel it will be R1 by 2. In case of a front wheel, we will only calculate the coefficient of rolling resistance, because this is a two-wheel drive tractor, the torque or the tractive effort is only developed at the rear wheels. Okay. So B sin alpha which I have given is 1.25 plus, right, I have 1.25 plus 2.1. We are taking moment about B, so plus 2.1. So that will be, so now after knowing the dynamic weight, next thing is we have to calculate Bn for front wheel, Bn for rear wheel, and where the del by H value is given as 0.2. So now for calculating the rolling resistance ratio or motion resistance ratio for front wheel, since there is no slip, so directly you can write as 1 upon Bn plus 0.04. So whatever value you are getting, just multiply with a 2. So the total motion resistance of front axle, that means for both the wheels in the front. So this expression into 2. Similarly, for calculating the motion resistance ratio of rear wheel, we have to take slip into consideration. 0.5 s by square root of Bn plus 0.04. So slip we can take as 12% is given. So substituting here, so this will be Bnr. So now you will find out what is the motion resistance of a single wheel provided at the rear axle. Then you multiply with 2 on this side, 2 on this side. So that will give you motion resistance of 2 rear wheels. Next thing is, what is the power which is developed? That means gross traction ratio. So for calculating gross traction ratio, we will again take the help of Brixius equation, which is given as Q upon Rw is equal to, his W is your dynamic weight, and whatever value we are getting as R2 will be equal to, R2 by 2 will be equal to Wd in one wheel. So that will be equal to 0.88 into 1 minus e to the power minus 0.1 Bn into 1 minus e to the power minus 7.5 s plus 0.04. So in this equation, Bn we have calculated Bn for the rear wheel, and s is given 12%, 0.12. So we just putting it, we can find out one of the wheels, what is the torque ratio, and if you multiply with 2, that will give you the total tractive force developed, total gross traction in the rear wheels. So you know the gross traction, you know the rolling resistance, so the net traction you can find out. Net traction ratio will be, this is only for the rear wheels, not front wheels. Now for the total rolling resistance, we have to consider both rolling resistance of 2 rear wheels as well as rolling resistance of both 2 front wheels. So we calculated net traction ratio, we calculated motion resistance ratio. The next thing is we have to find out tractive efficiency. So for calculating tractive efficiency will be equal to mu by mu g. So mu g I have already calculated this value. So this will be your total mu g. Mu is the net traction ratio, whatever you are getting, into 1 minus s. So that will give you what is the tractive efficiency of the tractor while carrying out the ploughing operation in that given condition. So basically, you have to consider in a 2-wheel drive tractor, the power which is developed is only from the rear axle, not from the front axle. That means the rear wheels are responsible for developing power, tractive power. And for calculating the total rolling resistance, you have to take sum of the 4 wheels, not only one wheel and the 2 wheels and the rear axle. So that you have to take into consideration. The next question is related to track. A tracked vehicle with uniform contact pressure weighs 155.68 kilonewton, and it has the option to be fitted with tracks of same contact area, which is 7.2 meters square but different dimensions. One set of track with width to length ratio as 1:3, the other one is with 1:4.5. If the vehicle is to be operated over a terrain which is characterized by exponent of sinkage n as 0.5, cohesive modulus of sinkage 0.77 kilonewton per meter raised to the power n plus 1, K phi frictional modulus of sinkage 51.91 kilonewton per meter raised to the power n plus 2, and cohesion as 5.17 kilopascal, angle of internal friction 11 degree, and modulus of sinkage, shear modulus of sinkage, shear deformation modulus as 5 centimeter. Under these conditions, we have to find out which one is the suitable pair of tracks which has to be recommended. So here what we have to do is a tracked vehicle. That means there will be two tracks, and sum of the areas of the two tracks are 7.2 meters square. That means each area will be 3.6 square meter. But one track is having length is to width ratio. If this is W, this is L, width is to length ratio. In one track it is 1:3, in the other track it is 1:4.5. So now we have to find out what is the width. Okay, so area will be W into L. So W will be equal to L by 3. So L by 3 into L is equal to 3.6 meters square. So now from here we have to find out what is the value of L. Similarly here 4.5, L by 4.5 into L is equal to 3.6 square meter. So this is better if I write L1, W1. So L1 will be equal to how much? So once you know L1, once you know L, then you can find out what is its width, W and W1. Now I have decided the dimensions of the track for two different conditions. The next step is what is the sinkage, Z0. So if this refers to vehicle A, this refers to vehicle B, 1:4.5, then vehicle A, Z0 will be equal to B P by Kc by B plus K phi raised to the power 1 upon n. Now P is nothing but weight divided by, if W by weight by W into L, and in this case this will be weight will be remaining same, only the dimensions will change. That means area is also same, so that doesn't make much difference. So pressure will be same for both the tracks. So P is given, Kc value is given, B will change. B means this will be here W, and in this case it will be W1. So better I should write W so that it becomes clear. P by Kc by W. So Kc value is given, K phi value is given, W you have calculated from here. Okay, so you can calculate Z0. The next thing is what will be the rolling resistance. So B means W, K, Z0 raised to the power n plus 1 by n plus 1. So it is basically W, K is nothing but Kc by W plus K phi, and Z0 you can substitute here, raised to the power n plus 1 by n divided by n plus 1. So this way you can calculate for rolling resistance of first track, rolling resistance of second track, which is having a length to width ratio, width to length ratio as 1:4.5. So, once you calculate rolling resistance, then you can compare which one is giving you lesser rolling resistance. Then comes your, what is the gross tractive effort or thrust which is developed, that is important. Thrust which is developed by the two tracks, even though their area is same. So, you can utilize this equation. F is equal to, this is the tractive. So, this is the tractive force which is developed. F is equal to AC plus W tan phi. W here is the weight in each track. 1 minus K by IL into I is the slip, into 1 minus e to the power minus IL upon K. K is the shear deformation modulus, which is given as 5. So, length of the track we have already calculated. So, you can calculate F for different values of slip at 10%, 20%, 30%, you can go up to 40%. And C value is given, phi is given, A will be remaining same for both the cases. Okay. So, this value is giving you the tractive effort developed by a single track. So, if you want to find out the total tractive force, then you multiply with 2. So, twice of this will give you the value of a total tractive force. You know the rolling resistance of the track, two different types of tracks. We know the total tractive force. Again also rolling resistance we have taken for one track. So, you have to multiply with 2. Okay. So, you know the tractive force, you know the rolling resistance, then you have to compare at different slip values. What are the tractive force you are getting for track 1, what are the tractive force you are getting for track 2, and then wherever you are getting higher torque, higher tractive force, that you have to select. To confirm that one again, you have to check the rolling resistance for both the tracks. That means you have to carry out comparison of tractive force for both the tracks and the rolling resistance for both the tracks. Then from there, wherever you are getting higher tractive force and lesser rolling resistance, that has to be selected. That has to be selected. So, obviously, we'll come to an end in the sense the track which is having higher length will give you better tractive force and lesser rolling resistance. This will be the conclusion from this problem. So, I have solved 3 problems which are related to, one is related to utilizing the Brixius equation for finding out suitable tire size. The other one is related to find out the dynamic weight, how to utilize dynamic weight in Brixius equation. And the third one is related to track, how to calculate rolling resistance and tractive force developed by a track, and then you can compare. So, using the tractive performance equations developed by Brixius, such as coefficient of traction, motion resistance ratio and tractive efficiency of a tractor can be computed. Thank you.